Hello everyone, my name is Tran, and my co-authors are Dr. Hae-Na and Dr. Hwan Park. Today I will be speaking about our findings on how to create more accessible data visualizations based on the characteristics of how people with ADHD interact with charts. Let's begin with two key definitions. Attention deficit hyperactivity disorder, referred to as ADHD, is a neurological disorder which manifests as symptoms of inattention, disorganization, and/or hyperactivity impulsivity. Accessible data visualizations are charts or graphs that are created specially to be comprehensible by people with diverse abilities. This includes correcting hues used within charts for color blindness accessibility, or reducing the number of animations used to aid people with epilepsy. As many of you have probably experienced, the amount of data which we interact with in our daily lives has risen, such as in the medical, political, social, and financial areas of our lives. Because of this, the need for daily data-driven decision-making has grown. It is important that accessible visualizations are created, since charts can help people to comprehend these growing amounts of personal data. We wish to study accessible charts with regards to ADHD specifically, due to the prevalence of adult ADHD today. One survey estimated the rate of adult ADHD around the world to be 2.5%. However, there is currently a limited understanding of the relationship between cognitive disorders and data visualizations, especially of ADHD and visualizations. Let's go over the details of our study. In collaboration with domain experts and based on our literature survey, we designed and tested hypotheses that consist of factors that might impact accessible visualizations for people with ADHD, including basic chart colors, the amount of text, the use of related visual embellishments or pictographs, and user preferences. Our first hypothesis was that people with and without ADHD would respond differently to certain chart colors. The first task tested color, specifically green, blue, red, and gray as a control. We asked participants to identify the location of the highest and darkest values in the heat map. Our second hypothesis stated that increasing the amount of textual annotation in charts will negatively impact the performance metrics of those with ADHD. We used line charts annotated by Stokes et al. 2022. Participants were asked multiple choice questions about trends found in the graphs. The text amount levels were ordered from least to most amount of text. The third hypothesis stated that the use of embellishments in charts will improve performances of people with ADHD. We tested plain bar charts using a single visual embellishment on the face, and pictographs. Participants were asked 3 types of multiple choice questions about the graphs. Min-max questions asked participants to identify the minimum and maximum number of cups ordered. Search questions asked participants to identify the exact value of a variable. Ratio questions asked them to identify proportions, such as which drink order made up more than 50% of all orders placed. The fourth hypothesis stated that people with ADHD will not prefer the charts that correlate with the best performance metrics. For each experiment of color, text amount, or embellishment type, we had a question which asked participants to rank their preferences for the tested chart components. An example of this is asking participants to rank the same data portrayed as a plain bar chart, a graph with visual embellishment, and a pictograph. We conducted a crowdsourced survey over Prolific. After data cleaning, our final survey numbers were 70 participants with ADHD and 77 participants without ADHD. Both groups of participants received the same survey, which recorded response times, accuracy scores, and their preferences for each of our chart variables. All stimuli were created using synthetic datasets. We will now discuss the major quantitative results of our study. For the color trials, the ADHD group was significantly faster than the non-ADHD group. Green charts had the significantly fastest responses in both groups. However, there was no significant interaction found between ADHD and color for response time, although we see the largest difference between the groups appears for the red charts. For accuracy scores, neither color nor ADHD was a significant factor. For the text amount trials, the ADHD group was also significantly faster than the non-ADHD group across all text levels. In addition, increasing the amount of text used in a chart increased response times for both groups. In accuracy, level 1 text stimuli had significantly greater scores than level 4 text stimuli in both groups, but there was no significant difference between the groups. For the chart embellishment type trials, the ADHD group was once again significantly faster than the non-ADHD group. There was also a significant relationship between a question type and chart embellishment type. In post-hoc analysis, we found the search questions had the fastest response times using plain bar charts. The min-max questions were answered fastest using pictographs, and the ratio questions had no embellishment type associated with significant differences in response time. For these same trials, there was no significant effect of ADHD on accuracy. However, there was a significant interaction between the question types and the chart's embellishment type, specifically found for the ratio questions. For those questions, the accuracy scores of both groups were highest when using pictographs, then plain bar charts, then charts using visual embellishments. For the search and min-max questions, there was no significant difference in accuracy between the embellishment type. Across all three chart components, we found that the preferences of participants with ADHD did not match the charts that led to the best performances. For example, in the text amount trials, those with ADHD significantly preferred the level 3 charts over the level 1 charts, despite the fact that they performed better using the level 1 charts in terms of accuracy and response time. From these quantitative results, we then drew conclusions and created preliminary design guidelines for charts. First, we explored why the participants with ADHD completed all tasks faster than those without ADHD. These results may be explained by the activation of hyperfocus, a state of high focus and attention. Hyperfocus has been documented to occur in people who have ADHD or autism. Necessary components for the activation of hyperfocus include interest, competitiveness, and stress. This heightened state of focus can help to account for why the group with ADHD performed tasks faster than the group without ADHD. We kept this in mind when making our guidelines. Our first guideline is to use similar color design tactics for charts that have people with and without ADHD as an audience. This means hypothesis 1 was not supported. Among the colors tested in this study, we did not find a significant difference in accuracy or response time between those who have and do not have ADHD. Therefore, we believe general graph design guidelines on best use cases of color can be used for both groups. This is beneficial because it opens the number of colors that can be used to encode meaning in charts, and it may be easier to make accessible graphs for a larger and diverse audience, such as in educational settings. Hypothesis 2 was supported. We found that general guidelines for the amount of textual annotation on charts may be applied to audiences that include adults with ADHD. Text annotations on a chart that are not relevant to the task can negatively affect response times and accuracy. Increasing the amount of textual annotations on charts appeared to negatively impact the response times of those with ADHD without significantly increasing their accuracy. It was also found that participants had significantly more accurate results when using the graph with few text annotations compared to the paragraph of text. This is supported by previous research, which found that an attention distractibility trait, measured by slow response time, significantly increased with irrelevant visual cues. Therefore, it is important to note that more textual annotations may be useful for both groups if the text is closely related to the questions and takeaways that we want our readers to understand, with no distracting or extra information included. This was reflected also in participants' comments. Some stated that they liked the extra contents given by adding more of the annotations, but it did not necessarily help them with answering the questions. We also found that general guidelines for the embellishment type that should be used for charts apply to both groups, but it depends greatly on the task type. Therefore, hypothesis 3 was partially supported. The use of pictographs improved the response times of participants with ADHD in the min-max questions and improved accuracy in the ratio questions. In addition, plain bar charts helped those with ADHD to more quickly answer the search questions with no loss to accuracy. Similar to the text-based tasks, an increase of visual stimuli used in a chart may be useful only if the images increase the perceptual load of the viewer. That is, the amount of task-related images should be significant enough to divert attention away from any distracting and irrelevant images. Finally, we found that designers should be cautious and deliberate when using more subjective measures, such as user preference, to influence chart design. Hypothesis 4 was supported. Across the entire study, the visualization preferences of participants with ADHD did not align with the charts that led to the best response times or accuracy. This gap between user preference and chart performance for people with ADHD may be explained by the priming factors of hyperfocus. Hyperfocus, again, has been found to be activated by both enjoyment and by stress. It is possible that for certain tasks in the survey, participants with ADHD were motivated by stress, which would lead to their high performance as well as their dislike of the charts. Therefore, understanding the preferences of a viewer with ADHD may be important in increasing engagement with data visualizations and lead to hyperfocus status by enjoyment, not stress. In this study, charts with visual embellishments were cited as being helpful in reinforcing the text. One participant described the charts with visual embellishments as more engaging, as it contains visualization of variable types, whereas the pictographs were unnecessarily complicated. This was not reflected by the performance metrics of response time and accuracy. There were limitations to this study that could be later examined or improved. We used a crowdsourcing service. In order to increase access to the survey, computers, phones, and tablets were all allowed as testing equipment. Thus, there was no guarantee that participants viewed the stimuli at the same size. The brightness of the screens may also have been variable and have affected the color identifying tasks. In addition, it should be acknowledged that since we used an online survey, we could not control the relative time that the participants took the survey. This may have a slight interacting effect with our results, since a previous study has found that learning later in the day is especially improved for those with ADHD. However, since the time at which a viewer interacts with data visualizations is not something that can be easily controlled in real-world situations, the effects of controlling the time of day at which experiments are conducted will need to be further contemplated. Finally, ADHD medicine can help to reduce, but not to fully eliminate symptoms of ADHD. We did not collect whether the participants had taken medication prior to taking the survey, which may have helped our participants with ADHD to have faster response times. However, the type and dosage of medication would also need to be studied, and the effects may be different for each person. This is something that can be considered in future studies. In this paper, we conducted a crowdsourced study that included both people with ADHD and people without ADHD to understand how those with ADHD comprehend charts. Our work expands upon and verifies previous discoveries to broaden the frontier of accessibility in data visualizations by understanding the differences in visualization literacy between people with and without ADHD. And the results led to preliminary suggestions for how to create more equitable data visualizations for adults with ADHD, with the goal of helping them to better understand their data. Thank you.